This video is about perimeter, area, and circumference.
So for perimeter and area of rectangles, let's start with an example. We have a picture of a rectangular garden with a walkway around it. That's the part that looks kind of gray. Is a uniform width walkway, so it's 4 feet wide all the way around. Types of questions you might be asked is, what length of fence would you need if you wanted to build a fence around the outer walkway? So let's say we want to put a fence all around the exterior of this walkway. It's a perfect example of a perimeter question. Perimeter means the length all the way around an object. So if we wanted to build a fence, we're talking about a length of fence that we would need to go all the way around this rectangle. The only tricky part is figuring out the length and the width of the outer rectangle. So this distance here is not just 16, because 16 is only the inner garden. It's going to be 16 plus 4 feet of the walkway on the left and 4 feet of the walkway on the right. So 16 plus 8, which is 24 feet. And then same on the other dimension, we want to do 22 feet for the inner garden, plus 4 feet on either side. So 22 plus 8, and that'll be 30 feet on that side. So that we can calculate our total length of fence needed. Total length is perimeter, so we use a capital P. And it's going to be 30 plus 30 for 2 of those, and 24 plus 24 for 2 of those, which will come out to 108, and the units are going to just be feet. Perimeter is a linear measurement, so length, and length is measured in feet, not square units. You might also be asked for something like, find the area of grass that is in the garden. So what is the area that the grass covers in the garden? So here we're going to assume that the whole area is covered with grass, even under these bushes and plants. So we're looking for this area, which is all of the internal space, two-dimensional space, inside of the garden rectangle. And now we can use the 16 and the 22 because those are the dimensions of the inner garden. Area, however, is a multiplication problem. It's 16 linear feet by or times 22 linear feet. So 16 times 22, and that'll give us the area of the garden, and this time the units will be squared because we've done length times width, or feet times feet. This comes out to 352. The units here would be feet squared, because feet times feet will be feet squared. So in case you're not familiar with the formulas, let's go ahead and write them down. You may see in a book a square represented with S on the side, and that's because all 4 of the sides would also be able to be called S. They're all the same length. So in our first figure, we have a square, the side is called S. The perimeter formula would be written as 4S, and that's because it's S plus S plus S plus S, for a grand total of 4S. And you might see the area formula written as S squared, because side times side, or S times S, would be written simplified as S squared. So you may see those formulas for a square, or you may just see the rectangle formulas, which we're going to write down here. In our rectangle picture, we have a B representing the base and H representing the height. They don't have to be the same length as each other. If B and H were the same length, then it would be a square. So if we have B and H, so our perimeter, once the formula is simplified, ends up being 2B plus 2H, because it's 2 bases plus 2 heights. And the area is just BH. So these are the formulas that you'd see in a book, and now hopefully you know where they came from and how they can be used to get the answers for the area, perimeter, or rectangle. Now let's jump to a triangle. This page is a little harder to see. See if I can zoom in on it a bit. Okay. We have perimeter and area of triangles. This is a map of Indiana. And I found 3 cities in Indiana, or towns, that appear to be on an almost perfect right triangle. So I drew a triangle in red, bold lines, I hope you can see it, between Lafayette, Noblesville, and Crawfordsville on this map. And questions you might be asked would be something to the effect of, if you wanted to build a highway or roads between these 3 cities, this direct route, what is the length of highway that you would need to build between these cities? So hopefully you can figure out, because it's asking you for a length. This is talking about a perimeter question. And the perimeter of the triangle up there is going to be the sum of each of those distances between the 3 cities. Now distance is the one thing that's lacking on this map. It doesn't show distance at all. But these are real cities, and you could go to the internet and find the distances. So let's say we want to do this in miles, and we go to a website, and we find the distance between Lafayette and Noblesville. So I'm just going to shrink this window and go to a browser, and we'll pull up a website that can be used to find distances between cities. There are many of them. One of them that I've been using is called distancefrom2.net, because this lets you find the air distance, which is like a direct distance calculation, rather than a driving distance. So let's say Lafayette, Indiana as our first city, and Crawfordsville. These are just the two names that I remember. Indiana as our second city, and I'm looking for the air distance. So you can see here it gives us distance in kilometers and distance in miles. I'm going to pull the miles one, so 25.98. We'll go back to where we're doing our triangle, and we'll find that it's 25.98. So we are actually applying real distances to this perimeter problem. I could then go back to that website and pull the other distances, which I've done in advance, so I'll write them in here. 45.85, 52.48, that's the longest distance. And by adding these three distances together, we can figure out that the total length of highway we would need is 124 31/100ths of a mile. Okay? Or an area question. Let's say we were spraying pesticide on a bunch of cornfields that are between these three cities. If we're going to spray pesticide or, bug killer, we're going to spray it on all these farms. What is the area that we need to spray? So we have to be prepared and make sure we come with enough material. Area for a triangle, if you look back up at the map, if you're not familiar with areas for a triangle, it may help to picture a triangle as half of a rectangle. It's really easy to see when you've got right triangles. So the green rectangle I just drew has the red triangle as exactly half of it. And the rectangle we just learned to figure out area by doing base times height. So it makes sense that for this triangle that we're trying to find the area of, we'll do a half times the base and the height of the rectangle. The base and the height of the rectangle were the horizontal and vertical distance, so it doesn't include that long distance that's split right through the rectangle. So we just want to use the base and the height. So it would be 25.98 and 45.85. Two sides that make a 90-degree angle with each other. Multiply these together, and the area comes out to 595.59. This time the units are squared. We ended up doing miles times miles, so we get miles squared. So let's write down those formulas just so we have them written down formally. Here's a picture of a generic triangle. The sides are now called A, B, and C because they could all be different. They could also have some the same, but since we don't know, we're calling them three different variables. Perimeter for a triangle is just written as A plus B plus C. And the area for a triangle is going to be 1/2 base height. It's important to note that the base and the height in this triangle or in any triangle when you're doing this calculation, have to make a 90-degree angle with each other. So if you get a triangle like this where it's not clear what the base is, and that's because any side can be the base. You can imagine that any of these three sides is on the ground, as long as the height that you draw with it forms a 90-degree angle. So let's say we're going to call this the base. If you imagine that this side is the ground, the height has to make a 90-degree angle with it, or come sticking straight out of that as if it was a flagpole coming out of the ground. So if you picture that B as the ground, then it's easy to draw the height as a flagpole coming out of it. So that's just kind of a mental image to help you form your height, making a 90-degree angle with your base. Then we jump into circles. For circles, it makes sense to do the formulas first. Maybe you're less familiar with circles. So for circumference of a circle, circumference is just another word that basically means perimeter of a circle. It's the distance all the way around it, as if you were going to cut like a string and tie it all the way around this circle, like how long that string needs to be. So for circumference of a circle, we use the formula 2 pi r. I'd like to think of this as 2r times pi. You can see, I hope, that that's the same thing. The reason I like to think about it that way is because 2r is twice the radius. And twice the radius is what we call the diameter. So this whole length is the diameter. It's just two radiuses put together. So in case you're familiar with the circumference formula pi d, I don't like this formula because d is just 2r. And so thinking of circumference as two different formulas is never very helpful. We can all just remember that it's 2 pi r, because 2r is the same as the diameter. So that's our circumference formula for a circle. Area for a circle is going to be pi again. Pi's got to be there in the circle formula, times the radius squared. So area, as we know, needs to have square units. It needs to be like miles times miles or feet times feet. And we don't have something like a base and a height for a circle, right? So we need to multiply the radius by itself. So the radius by the radius so that we can get our square units. So these are the two formulas that we use for circles. Let's go ahead and apply them. We'll find the circumference of the first one and the area of the second one just because. So the circumference formula we want to use is 2 pi r. It's important to look at the picture and be able to get the radius. It's half of the diameter, and half of 15 is 7.5. So that's just this distance is the radius. And then, of course, 2 multiplied by 7.5 is going to be that 15 again. But I like to go through the whole process of using the formula. The units on circumference are inches. Just like perimeter, it's just a linear distance. And area is pi r squared. So for here, we've got 4 squared. 4 times 4 is 16. We're just going to leave our answers in terms of pi, rather than taking out a calculator and using the pi button. Units for area are going to be squared. So I hope that that is sinking in. All perimeter and circumference, the units are not squared. They're just linear. All area, the units are going to be squared. Because you have to do like centimeters times centimeters. When you do a unit times itself, it ends up being squared. And then the final piece of the puzzle is what happens when you put various shapes together. The area addition postulate that I put at the bottom just basically says the area of a shape is the sum of all of its parts. So if you wanted to cut this up into some different pieces and add them together, you get the area of the overall shape. So in my first shape here that looks like some stairs, it helps me to picture it divided into these 3 pieces, basically a square, and a rectangle, and a slightly bigger rectangle. Because I can get those 3 pieces. The square is just a 3 by 3 square at the top. The medium-sized rectangle is 3 on the height, and it's going to be 6 across, so 3 times 6. And the largest rectangle is 3 for the height, and 9 all the way across. And sometimes they show more information on the picture than you really need, and of course there are other ways to divide this picture up and figure it out, but this way works just fine. It ends up being 9 plus 18 plus 27, which is 54, and the units here are centimeters squared because we were looking for area. Next one is a rectangle and a triangle. I hope you can see that this is the easiest way to divide it. Where the rectangle is 12 on the bottom and 4 tall. So we've got area 4 times 12 for the rectangular piece. Plus, and remember triangles are 1/2 base times height, so we can start with the 1/2 automatically. We just have to figure out the base and height of the triangle. So the triangle's base is here. Now it's not going to be 12 because 12 would be the whole distance. But if you had this piece added in, then it would be 12. And this piece, because it has a single dash in it, must be 4. So if you've got 12 and you're taking out that piece, that is 4. And the base of our triangle must be 8. And the height of it is 4. It has a single dash in it. So we perform these calculations and add them together. 4 times 12 is 48. Half times 8 times 4. Should be a plus 9. Half times 8 times 4 is 16. And 48 plus 16 is 64. Units are squared for area. And that is it.